Recursive sequences. So we're going to talk about stuff now that isn't necessarily arithmetic or geometric. It has its own separate pattern. So we don't have that addition of the same common number. We don't have that multiplication of the same common number. So if I take a look at question number 1, it looks to me like I am adding. So I see from 2 to 5, looks like plus 3. See if we can establish some sort of a pattern here. From 5 to 10 is plus 5, and then from 10 to 17 is plus 7. So it's not necessarily the same number, however, I do see a pattern in the numbers themselves. 3, 5, 7. I think the next number I'd probably add is 9 and then 11. So I think I'm supposed to be adding odd numbers. So what I'm going to do instead is I am going to write out what I have. So remember that n represents what term number it is, and we're still going to stick with the whole idea of t of n. So I would say t of 1, so the first number in my sequence is going to be 2, and t of 2, the second number in my sequence, looks like it's 5. All right, so I know just by looking at these two that to find t of 2, I have to take t of 1 and add 3 to it. All right, well, let's do this a couple of times over and see if we can come up with some sort of a pattern to relate these guys together. All right, let's put 2 and 3 together. So the second term is 5, the third term is 10. So I know that t of 3 is going to be equal to t of 2 plus, not 3, 5. Okay, last one. So I know that t of 3 given is 10, and t of 4, which was given as 17. All right, so still just doing what I did previously with the idea of adding 3, adding 5, adding 7. I'm just trying to get some notation involved here. What I want to do here is come up with some sort of a pattern with the 3, the 5, and the 7. And I think I found it. If I take a look back at that, and I'm going to underline these guys. If I take a look at this 2 and that 1, I know that if I add those together, that gives me the 3 number right there. All right, let's see if that works here. I'll take the 3 and the 2. If I add those, I get the 5 right there. Okay, looks like I'm looking good so far. So add the 4 and the 3. That gives me 7, which is the number right there. All right, so I just need some notation. So I think what I'm going to do is I'm going to copy one of these down a little bit lower here, because I don't really have much room there. So t of 2 is equal to t of 1 plus, and let's put some brackets around this. It's 2 plus 1, the two numbers being added together. All right, so I want to base this off of my t of n. So if n is 1, then 2 is going to be n plus 1 plus brackets. Okay, the 2, this 2 corresponds with this, which corresponds with my n plus 1. So it's going to be n plus 1 plus this 1 corresponds with that, which corresponds with my n. So plus n. So I think I have an equation. Let's just clean it up a little bit. So t of n plus 1 is going to be equal to t of n plus, if I put those together, I'm going to get a 2n plus 1. And there's one other thing that you need for a recursive, and you have to have something to start with. So in this case, notice that t of n is t of n plus 1 is reliant on t of n. So I need just one term, and we normally like to have the first one, and that first term was 2. So my equation, my entire equation for this thing is going to be, or my entire formula for this is going to be both of these pieces. The formula that generates it and the value that actually starts it. Okay, moving on to number 2. Now we actually have something already set up for us, and our job is just plug stuff in. So if t of 1 is equal to 3, then that means that my n, the first n that's given to me, is 1. So this is saying that n is 1. So I'm going to go to my generator, and everywhere I see an n, I'm going to plug 1 in. So it's going to be t of 1 plus 1 is equal to negative 1 to the, all right, there's another n, times 5t of 1. Now my job is just plug in what I know. So adding these, I'm going to get 1 plus 1, which is 2. It's going to be negative 1 squared times 5. T of 1 was 3. That was given to me. So t of 2 is negative 1 squared is 1. 5 times 3 is 15. So I think t of 2 is going to give me 15. And I'm going to go ahead and just start writing my sequence off to the side. So my first term was 3, because that was given to me. The second one I just found is 15. And let's find at least one more. So now, looking at this, it looks like now my n is going to be 2. So there's my n. Now I just plug it in again to the equation. So t of n plus 1 is going to be equal to, excuse me, negative 1, there's another n right there, times 5 t of, and my n is 2. Alright, so t of 3 is equal to, it's going to be negative 1 cubed times 5, t of 2 is 15. So t of 3, negative 1 cubed is going to give me negative 1, and 15 times 5 is going to give me 75. So it looks like t of 3 is going to equal negative 75, which I can now add to my list. And 3 terms is enough to set the precedent for a sequence.